there.
It's like, because I saw an email from Sienna on Friday, basically saying.
Hey!
So I didn't know if
Look at Daddy right
I
there.
don't know why. But it's funny because
What's that $2 bill?
Okay, so last week we started talking about integration. We did basic integration and then we did FTC part 1. Any questions on any of that stuff? Okay, so also remember you need to know how to use your calculator to evaluate definite intervals. That's an important thing too. Okay, so today we're going to just talk about another technique of integration. It's called integration by substitution. Sometimes this is just called U substitution. U substitution. That's what it's commonly known as worldwide. U substitution. And this is the technique that I was telling you about that's more or less the chain rule kind of backwards. So this is roll backwards. Sort of. Okay. So I think the best way for me to do this is just go through an example and then write the steps as we go, and then do a few more examples. Okay. So let's suppose the problem we're trying to evaluate would be the integral of 2x times x squared plus 1 to the 23rd power. So obviously without this method, this would be really difficult, right? You'd have to like FOIL out x squared plus 1 times x squared plus 1 times x squared plus 1 23 times, and then distribute the 2x, make it into a big polynomial, and then just integrate it by term by term, which isn't reasonable at all. But you can kind of look at this and see that this is kind of like the result of a chain rule. I mean, with some weird stuff happening. Like, you know that to get the 23rd power, it would have had to originally have been a 24th power, right? But then you would have had a factor of 24, which isn't here, if you were to take its derivative. So, I mean, you can sort of think about how this is kind of like the chain rule. 2x is the derivative of x squared plus 1. So that's kind of like nice there. Yeah, go ahead.
Will this be like 124 times x squared plus 1?
To the 24th.
The 24th.
Yeah, it seems like that's what it would end up being. But it's not always going to be like you can just figure it out like that. Sometimes it'll be a little bit more complicated. So I think you're right about that. But let's just go through the process, and then you'll see like that there isn't any guessing involved or anything like that. It would be really hard, I think, if you had to guess on each case and try and check it. I think that would be a harder way to do it. So let's just go through it. So step 1. Is to pick a u. Okay, so I'll go into that a little bit more later, but for now I'll just tell you what it is. You're just going to pick something to be u. So in this case, u is the stuff that's in parentheses. U is going to be x squared plus 1. Okay, so pick a u. More on this later. For the first few examples, I'll just tell you what u is. Okay? And you'll probably be able to sort of deduce how I'm picking u after we do a couple examples. Okay? So that's the first step. Pick a u. The second step, step 2, is to find du dx, which is just simply the derivative of u. Now this might seem weird. We're doing integration, but in order to do integration, one of the steps is to find a derivative. That seems weird, but that's the process, okay? So I'm gonna do du dx, in this case is 2x. Just like normal, that's the derivative of x squared plus 1. It's 2x. Okay, step 3. Is anybody confused yet? Okay, good. It might get a little confusing here. Step 3 is to, this is a little bit weird. You're going to solve for dx. Pretend like this is like a separable fraction that you can like cross multiply to get dx by itself. Now, I've always told you that the dx is like one symbol that you can't really like separate. It's not really intended to be like a fraction. This is like the derivative of u, right? But for these types of problems, we're just going to pretend like it can be cross multiplied and separated out, and we can solve for dx. So that's what I'm going to do. I'm going to cross multiply u equals 2x dx, and then I'm just going to divide by 2x. So I get dx equals du over 2x. Everybody okay with that? Again, that's a little bit weird, but you'll see everything will kind of work out in the end. Okay, step 4 is to substitute in for u and dx. So if you look at our original problem here, our original problem was the integral of 2x times x squared minus 1 or plus 1 to the 23rd dx, right? So what I'm saying is we know that this whole thing right here is really u, and we know that this thing right here is really du over 2x. Those are the two things we're going to substitute in. We're going to substitute u in where it goes, and we're going to substitute dx with what its equivalent is that we just found in the previous step. So if you do those two things, you get the integral of 2x times u to the 23rd times du over 2x. And you can see what happens. What happens here is 2x on top, 2x on the bottom, they actually cancel, right? 2x cancels with the 2x, and you get the integral of u to the 23rd du. That should always happen. Anything that has an x in it should cancel. If it doesn't, then you pick the wrong u at the beginning, or you made a mistake somewhere along the way. Okay? So at this step, all x's should cancel. Okay, and that's what happened here. So step 5, now we have an expression that's easily integrable, right? The integral of u to the 23rd du, like that's easy to integrate. It's just a simple little polynomial term, right? So step, I don't even know what step I'm on, 6? 5? Step 5 is to just integrate. So if I have the integral of u to the 23rd du, what is its integral? Yeah, it's u to the 24th divided by 24 plus c. Right? And the final step is just to substitute back in for x's. Step 6 is to substitute x's back in. So u was really, if you look way up in step 1, was really just x squared plus 1. I'm just going to substitute that back in. So this is going to be x squared plus 1 to the 24th divided by 24 plus. And that's the final answer. If you differentiate that, you get what the original integrand was. So you're right. You got the right answer. Okay? Let's try another one that maybe isn't so obvious, and we'll do the steps, all the steps. And you'll see it's not as long of a process as it looks like when I write all the steps out like this. It's not that bad. Okay, so let's try another one. How about this one? What if I had the integral of cosine cubed x sine x? Okay, so step 1 is to pick u. So I'm just going to tell you u is cosine x in this problem. So u is equal to cosine x. Step 2 is to differentiate u. U dx is equal to negative sine x. Now solve for dx. So du is equal to negative sine x dx. And dx is equal to du over negative sine x. Now you make the substitution. So cosine x was really u, so this is really just the integral of u cubed times sine x times dx, which is du over negative sine x. At this point, everything should cancel that has an x in it. And it does, right? The sine x cancels with the sine x. Good to go. So now this is really just, there's a negative constant that didn't cancel. So you can write that negative either in front of the u or outside the integral even, because it's just a constant multiple. I could write this as negative integral of u cubed du. So when you integrate that, you get negative u to the 4th over 4 plus c. And the final step, don't forget to change back into x's. The answer is negative cosine to the 4th x over 4 plus c. And if you check this mentally, it definitely works out, right? Here's the check right here. The derivative of this stuff would be negative 1/4. That's just a constant multiple times 4 cosine cubed x times the derivative of cosine, which is negative sine x. And everything cancels. The 4's cancel, the negatives cancel, and you get the original integrand. Does that make sense? So the steps are all here. Step 1 was to decide what u is. U are? No, u is. Step 2. That's a good one, right, Luke? Step 2 was to take a derivative. Step 3 was to solve for dx. Step 4 is to make the substitution. Everything should cancel that has an x in it. Step 5 was to integrate. And step 6 is to substitute back into x's. Does that all make sense? Let's do another example. Then we'll talk about how I'm picking what u is. So how about this one? What about the integral of 1 over radical x times sine of radical x dx. Does anyone have a guess? What do you think you might be in this problem? What do you think, Eden? No? Any other guesses? It's just radical x. Is that what you said?
Yeah.
Yeah, it's radical x. So let me just show you a little shortcut. It's not safe, it won't save a ton of time, but it'll save you a little bit of time. This step right here is always the same, right? You always differentiate, then you cross multiply to get this expression, and then you divide. So a shortcut would be just jump right to the second step. Write this as du equals 1/2 x to the negative 1/2 dx. Right? You're saving yourself one line of work, which might seem insignificant, but you know, if you do 4 or 5 of these on the AP exam, you're saving yourself a little bit of time. So dx is equal to, now this is really 1 over 2 radical x, so this would be 2 radical x du. Right? Everybody okay with that? Now you substitute in, this is the integral of 1 over radical x times sine u times 2 radical x du. And you can see the radical x cancels with the radical x. So this is really 2 times the integral of sine u. That 2 didn't cancel. So the integral of 2 times the integral of sine u would be negative 2 cosine u. Right? The integral of sine is negative cosine. So the answer is negative 2 cosine radical x plus. All right, so let's talk about how to decide u is. So these are helpful hints for picking u. So there's 2 kind of basic rules that are usually followed. Not always, but usually. The first thing is that often u is just whatever's in parentheses in the problem. Now, sometimes the parentheses are like implied and they're not really there, but often u is in parentheses. Or implied parentheses. So if you look at the 3 examples we've done, the first example, u was definitely in parentheses, right? And that's what it ended up being. In the second example, they were implied. This is really cosine of x all cubed, right? This is just a shorthand way of writing that. There really were parentheses around cosine x. You just can't see them. And then in this problem, kind of the same thing. You're taking the sine of something. Okay, there wasn't actually parentheses there, but there could have been. Okay, so I mean, that's kind of a helpful hint. It works sometimes, it doesn't work always. The second one works more often. For the second thing, u prime or a constant multiple of u prime must be a factor of the integrand. Okay, so let's go through the three examples again. If you look at the first one, u prime, this was u, right? U prime would be 2x, and there it is right there, a factor of the integrand, 2x. If you look at the second example, we picked u to be cosine. Its derivative is negative sine. Well, here's a constant multiple of that, right? This is -1 times negative sine x. It's a constant multiple of the derivative of the thing that we wanted u to be, which is cosine x. Same thing here. If you pick this to be u, its derivative is it's 1/2 x to the -1/2. Well, here's a constant multiple of that right here. It doesn't have the 1/2 attached to it, but this is a constant multiple of the derivative of radical x. Does that make sense? So that has to be true. U prime, or a constant multiple of u prime, has to be a factor of the integrand. Okay? So let's do a couple more examples. What if I have this one? How about the integral of 3x dx over the square root of 4x squared plus 5. Sometimes with integrals, they'll write dx like as part of the fraction, like in the numerator of the fraction, instead of writing it out by itself. It's okay, don't let that confuse you. It's just written a little bit differently. So what do you think u would be in this problem? Remember the two rules. Often it's in parentheses or implied parentheses, and u prime, or a constant multiple of that, has to be a factor of the integrand. So what do you think? Any ideas? I won't yell at you if you get it wrong.
4x squared plus 5.
Yeah, 4x squared plus 5. Because if you think about it, it's in parentheses, right? It's like something to the -1/2 power. And in addition to that, its derivative is 8x, and here's a constant multiple of that right here. So all the rules are satisfied. Does that make sense? Okay, so now another mistake people make is they'll say 4x squared instead of 4x squared plus 5. But you want to have u be like as much as possible and still have it work, so that in the end, you just have a simpler expression to integrate, right? Because think about if you had u just be the 4x squared, this would be the square root of u plus 5. It's still like more complicated than just the square root of u on the bottom. Okay? So u would be 4x squared plus 5. Du is 8x dx. Differentiate. Divide by 8x. So dx equals du divided by 8x. Then make the substitution. So this substitution would be 3x times du over 8x over u to the 1/2 power. And you can see what happens, that the 8x and the 3x can reduce to be 3/8. Everything that had an x in it canceled, which is what we wanted to happen. So now this is going to be 3/8 the integral of u to the -1/2 du. This is 3/8 times u to the 1/2 times 2. So this simplifies to be 3/4. So this is 3/4 radical 4x squared plus 5 plus 3. Does everybody understand that? Let's do another one. I have how about this one? The integral of e to the tangent x times secant squared x What do you think? What's u? No, it's tan x because you want its derivative to appear somewhere, and there's the derivative of tangent x right there. If you had u be secant x, its derivative is secant x tangent x, which there's no factor of tangent x here anywhere, so that wouldn't work. Does that make sense? The reason why y prime has to appear somewhere, or a constant multiple of it, is so that you can have all the x's cancel at some point. Because if it's not a factor of u prime, if u prime is not a factor of the integrand, then there's going to be an x that's left like uncrossed off. Does that make sense? That's the reason why that's true. So u is tangent x. So du is secant squared x dx. Dx is du over secant squared x. Then you substitute. So this is e to the u times secant squared x times du over secant squared x. Perfect. They cancel. So this is just e to the u du, which has an integral of e to the u plus c. So the answer is e to the tangent x plus c. How about this one? The integral of e to the x over 5 plus e to the x dx. What do you think here?
Yeah. 5 plus
5 plus e to the x. U is 5 plus e to the x. So du is e to the x dx. Dx is du over e to the x. So the substitution would be e to the x over u times du over e to the x. And those cancel. What's the integral of 1 over u? ln u. So this is just going to be ln u plus c ln of 5 plus e to the x plus c. Are you kind of getting the hang of this? Let's do one more. Let's pick the one that looks the hardest out of all these that I have here. How about this one? The integral of 1 over theta squared sine 1 over theta cosine 1 over theta. Theta. The thetas make it harder. So what do you think? Isn't it just theta? It's never going to be just theta. Here's why. Because the derivative of theta would be 1. And if you did all the work, you'd have the exact same integral, except instead of having thetas here, you'd have u's here. So you're not making it any simpler by letting u be theta. Does that make sense? You're never, ever going to just have u be theta, because it doesn't help anything. Any other guesses? This is a hard one.
Sine theta, or
Yeah, it's sine 1 over theta, right? Because think about it. If it's sine 1 over theta, its derivative is cosine 1 over theta times negative 1 over theta squared. Well, here's a cosine 1 over theta and a 1 over theta squared. That's a constant multiple of u prime. Does that make sense? This is going to be sine 1 over theta. So du is equal to cosine 1 over theta times negative 1 over theta squared. d theta. Right, chain rule, the derivative of theta to the -1 is -1 over theta squared. So then d theta, well, this is in the denominator, so it's going to be in the numerator, theta squared over cosine 1 over theta u. So then substitute in, this is going to be 1 over theta squared times u times cosine 1 over theta times negative theta squared over cosine 1 over theta du. The theta squared cancels, and the cosine 1 over theta cancels. You still have a constant negative there, so you have to be careful that you don't cancel that off. So this is really negative integral of u du. So you took a really complicated looking integrand and turned it into this just by substituting. So this is just negative u squared over 2. So the answer is negative sine squared 1 over theta over 2 plus c. We actually could have picked a different u here. We could have picked cosine theta, because its derivative would be negative sine, or cosine 1 over theta. Its derivative would be negative sine 1 over theta times negative 1 over theta squared. It would have worked also. Okay. Let's do that, actually. I think that's interesting. Let's take the same function, 1 over theta squared, sine 1 over theta, cosine 1 over theta, d theta. So this time, let's take u to be cosine 1 over theta. So du would be negative sine 1 over theta times negative 1 over theta squared, d theta. D theta would be, the negatives cancel, so you get theta squared over sine 1 over theta du. Now if you substitute that in, you get 1 over theta squared times sine 1 over theta times u times theta squared over sine 1 over theta du. So things cancel again, but this time there's no negative. So this ends up being the integral of u du, which is u squared over 2. So it's cosine squared 1 over theta over 2 plus c. So I have a question. Here's one function whose derivative is that. Here's another function whose derivative is that. How can you have two functions that aren't equal to each other? Because these functions definitely aren't equal to each other. But how can you have two functions that aren't equal to each other that have the same derivative? What must be true about these functions? It's a hard question. What's that? Kind of. Yeah. What do you mean parallel?
Will they opposite slopes?
No, they have the same. They have exactly the same derivative.
Any given point, there's slopes.
Yeah, okay, so let's think about what that might look like. Like if I have one function, f of x, like this, right? And I want to find a function that has exactly the same derivatives at every point, but it's not the same function. It would have to be like a vertical translation, right? It would have to be like this function, roughly, right? This would have to be like f of x plus something else, right? Plus something, or minus something, or whatever, right? So it must be true that these two functions are actually vertical translations of one another. don't know. Let's check it graphically. I think this is interesting. So the first one was negative sine squared 1 over theta. So if I take negative sine squared, I guess I have to put in parentheses, sine of 1 over x, and then square that whole thing, divided by 2. Yeah, divided by 2. Divided by 2. So let's graph that first. So let me do zoom tree. Okay, that's interesting. I think my calculator might not be in radians. What is? Okay, that's interesting. Okay, so now let's do the other function. So the other function, there was no negative sign. It was cosine of 1 over x squared divided by 2. So let's graph that. And you can see they're definitely, like if I get rid of the axes here, the axes are making it more confusing looking. If I go format, I can erase the axes. And you can see they look like parallel curves. Not in the same sense of parallel lines, but kind of. They don't intersect, right? You can see that they look pretty much exactly the same, just a vertical translation of the other one. It's like the Wonder Woman symbol. I love Wonder Woman. Okay, it just got weird in here. Any questions? Okay, so I'm going to stop recording now to get rid of the evidence.